Guys, Dev Party here, and today I'm going to be showing you how to make a custom terrain editor in Unity. So the first thing we're going to want to do to make a custom terrain editor is make an object, and we are going to call this terrain chunk, because we're going to split this up into chunks at the end of the series and make it an infinite terrain like thing. It's going to be pretty cool. Alright, so now that you have your chunk, go ahead and add some components. Just type in mesh in here, add a mesh filter, a mesh renderer, and a mesh collider. You can leave all this like extra stuff blank. And now that we have all the basic setup done, we need to make a script. But I like to keep things organized, so go ahead and make a folder called scripts. Scripts. Alright, open that up, make a C# script, and call this terrain chunk. Perfect. And once that loads, just put it on your terrain chunk and open it in your text editor of choice. Alright, now that you have your terrain like chunk script open, we're going to need to do some stuff. The first thing we want to do is make a private variable. We're going to call this private mesh, main mesh. This will be the mesh that is shown on the screen. That's what we're going to learn today. I'm going to show you how to make custom meshes in Unity. So let's go ahead and say main mesh equals new mesh. And maybe we should also have a couple other private variables such as private mesh filter and MF and private mesh collider MC. Alright, and we're gonna go ahead and say MF equals GameObject.getComponents component and mesh filter. Alright, now we have the mesh filter assigned. You're going to say MC equals GameObject, if I learned how to spell, .getComponent, mesh collider. Alright, perfect. And now that we have this, go ahead and load back into Unity. And now that we have this, you could press go. But you're going to see that nothing's obviously going to happen because we haven't set any meshes to the mesh filter and mesh collider yet. And we also haven't actually added any triangles or vertexes to it. So we're going to go ahead and add two new variables. I know this has a lot of stuff. Private vector3 array. And we're going to call this verts. And we're also going to have a private int array tries. Perfect. And now let's make a comment in here that says mesh generation. And then we can have some code. And then we're going to have the render mesh, which is when we're going to set the mesh render stuff. So let's go ahead and do this part first. So we're going to say mf.mesh is equal to main mesh. Perfect. And we are going to say that mc.sharedMesh is equal to main mesh. And now it's going to set these things so we can go into Unity, let it reload, and when we press play, we're going to see in here that it sets it to a mesh. It doesn't have a name, obviously, because we don't set the name of the mesh. We don't really need to unless you're making like a super serious thing where you need to see the name of the mesh for debugging. But I'm going to go ahead and assume you don't. So in here, for the code of the terrain generation, first up here we're going to specify a public int chunk size. I'm going to make this 16 like Minecraft. We're going to say for int x equals 0, x is less than 16, x is less than chunk size. This is what we just made. This is so we can specify the size of the chunk we're going to make, x plus plus. And then we're going to do the same thing for a y variable, like this, for int y equals 0, y is less than chunk size, y plus plus. And now we have two variables for the position of a vertex. So what we're going to say is main mesh we're actually going to add this to verts. Verts dot add. Now, you're going to see that you can't really do this in this specific context. So what we're actually going to do up here is say that verts equals new vector3 array. And the size is going to be chunk size times chunk size. And this will allow us to go ahead and specify an array with bigger bounds. Perfect. And instead of doing verts.add, we're going to say verts of x. Well, we're going to say verts of I. And we're going to specify what I is in a second. We're just going to say int I equals 0. And then up here, after this, I++, verts of I equals new vector2, vector3. This is a vector3 array. And we're going to say x 0.0f y. And obviously, as you all may know, these are split up into triangles. So we're going to need to make 3 vertexes to make a triangle. And once you do this, we're going to need to like change some values here to make the actual triangle. So what I'm going to do first is I'm actually just going to show you without these for loops. We'll go back to this later, but for now I just want to show you how to make a quad. So we're going to say this, and we're going to just hard code the verts length. We're going to say four vertexes, and I'll say that in a second. And while we're doing that in a second, and tries equals new int array. And I want to say this is 6 because for obviously a quad, you're going to need 4 vertexes and 2 triangles. Then you might be asking, why is there 6 here? Well, this is an int array. The triangles array is something like this. You have like vertex 1, vertex 2, vertex 3, and that'll specify a single triangle. So that's why it does that. And we're going to specify one more vertex. So let's copy and paste this again. And let's specify some coordinates of... Oh, wait, yeah, we need to actually specify just coordinates here now that we don't have x and y. So I'm going to go ahead and type these in. Now, obviously, if we're making a quad, this isn't going to work. As you can see, because these are all like the same vertexes, it won't really work. So we're going to need to specify some things. So what we're going to do is we're going to say minus, and we're going to say 0.05f for these, and we're going to say minus 0.05f for these. And then in here, we'll just make these all 0.5, and positive, negative, positive, negative. And these are all the vertexes we need to make a simple quad. Now we need to set the tries array. So let's say tries of I is equal to this. Is equal to an int, which we're just going to say 1. And instead of actually setting them with I, again, we're not in a loop right now, so just set them like this. It'll make a lot more sense what we're doing once we have a bunch of terrain, but for now we have to do it like this. This is like the essential stuff on how you make a quad for a mesh. So say tries of 0, 1, 2, 3, 4, 5. And then we have a tries array with 6 lengths. So this should be vertex 1, vertex 2, vertex 3, vertex 2, vertex 3, vertex 4. Now we have to make sure that these are going in a counterclockwise fashion, just so they're actually able to render. I think it's counterclockwise or clockwise. It's one of those two. So let's go ahead and see if this works. And also after this, we need to say main mesh dot vert is c's equals verts main mesh dot triangles equals tries, and then main mesh dot recalculate normals. Now this is just so it'll actually actually use lighting, because if it's not using lighting, nothing's gonna work. Mesh does not contain, I don't think I spelled vertices right. Vertices. Wait a second. Alright, I have figured it out. I totally didn't go to Google for that. Alright, now that we have this all made. We're going to go ahead and set a material in here. As you can see, it's none. It'll look wrong. We need to set this to one of these two. I'm just going to choose this one because I think it looks a little bit nicer than the other default material. We did this as if we were counting from normal. We actually have to count like this. And then it will work. Alright, let's go back. Sorry for that error. But other than that, everything should work now in theory. As you can see, we have one triangle facing up. And if we go down here, it's one triangle facing down. Now, this is because I accidentally messed up the indexing from one of them. I'm going to go ahead and guess this one. So if I put that and switch those two, it should, in theory, give me a quad. Oh, never mind. So, if I was actually good, then I would be able to see these things, but I'm not, so you're just gonna have to deal with it. So now if we press play, we'll see that we have a quad, and if we go into our scene, we have our own custom mesh that is attached to here. We can switch the positions around and it'll follow it. So, essentially, when you set a vertex position, it will not be relative to the scene. It is relative to the object the mesh is on. So, let's say you set this maybe an extra, like, you can see it's at 0.5, right? But if we press play and move around the object, this X is clearly not at 0.5. It's at, like, whatever this position is, minus 0.5, which would be that, 1.186. So, obviously, it's local to this, which can be useful for making things like terrain when you want to move them around. Alright, thank you guys for watching. Next video, we will be teaching you how to make your own, like, big chunks of mesh. I will see you all next time. Bye.